presenting my case study assignment for building elements and architectural technology, and this presentation will include 3 case studies in total. So I'll start with my case study number 1, which is the urban farming office located in Ho Chi Minh City in Vietnam. Vertical farming with office function, and it used facade system to tackle the urban food insecurity and to reduce the heat in the tropical climate as well. And the key system that I study is the facade is composed of concrete structure, and the hydroponic trays grow edible plants like mint and lettuce, and shaded with UV resistant trays, and supported by a drip irrigation system, which also alternating the terrace and open corridor, which create a natural cross ventilation, which significantly reduce the solar heat gain of the building. And in terms of structures and materiality wise, the structural frame consists of reinforced concrete slab with drop beams to support the additional loads of the vegetation and soil. And the facade also used the standard glazing behind the plant system, modular and climate adapted, which is offering a high impact with low capacity. And for the impact on the building performance, where with the application of this technology, the interior temperatures were recorded 1 to 5 degree lower compared to the conventional office, and the hydroponic facades and passive design strategies is reduce the cooling energy demand by 30%. And another one is like the green wall also serve as a public educational feature to enhance the awareness of the sustainable urban living. The second case study is Kampong Admiralty, which is located in Singapore. Kampong Admiralty is Singapore's first vertical village integrating residential, healthcare, commercial, and public facilities in a single high-dense development. It is a prototype of aging-in-place design that adapts tropical architecture into socially sustainable form. The integrated rainwater harvesting system is one of their sustainable water management, which include the multi-level water capture system, where the terrace garden was act as the bioretention basin, and it also used the gravity-fed system that collects the rooftop rainwater into a storage tank, as shown in the diagram, and the water is distributed via the timer control drip irrigation network to each planter box, and it also functions as a closed-loop cycle where it nourishes the plant, contribute to evaporative cooling, and the eco pond at the ground level also captured the overflow and support the aquatic life like fish and turtles, and it also acts the cooling and natural biodiversity in the public plaza as well. The construction methods and material used in this building is by combining the modularity and the natural expression. So the primary material used in this building is reinforced concrete, precast, facade panels, and glass and aluminum for the glazing and lightweight farming. And the building utilized the standardization and coordination by using the modular bathroom or kitchen pods in the apartment, and barrier-free accessible layout with the universal design. The building also integrated landscaping, like for example, the roof of the medical center was over-engineered to support the deep planters and trees. And in terms of social impact and environmental metrics, Kampong Admiralty is a green landmark platinum certified, which has like 51% of lighting energy is supplied on site and solar, and the rain harvesting saved like 1.5 million liters of potable water annually. And also like the passive cooling reduced the aircon load by 50%, and socially it also improved the health outcome by offering the easy access to the greenery, recreation, and healthcare, and all in one building. Moving on to case study number 3, which is Rexcale Community Hub in Malaysia. Rexcale, which located in Kuala Lumpur, was a famous adaptive reuse project which transforming an old cinema into a vibrant cultural and commercial community hub. Well, despite its cultural success, the building has performance limitation which related to the daylighting, ventilation, and overall environmental sustainability. And the issues and problem in the building performance included the insufficient building envelope, which the concrete facade on the rooftop was lack of insulation and shading, which increasing the internal heat gain and reliance on the mechanical cooling. And the second one is inadequate ventilation, which limited the openable windows and opening causes the overheating and reduced air quality. The third one is poor natural daylighting, which particularly on the upper level bookstores and the retail area, which due to a fully enclosed ceiling. Overheating under a large roof span, which especially on the upper level as well. And the additional one is the basic rainwater drainage, which has no use of runoff. So the first proposed advanced technology solution for the issue of poor daylighting in the upper bookstores due to the enclosed concrete roof is to install the semi-transparent building integrated photovoltaic, which is BIPV glass panel, to replace the section of the roof slab. And these panels allow the light in while generating electricity, where this system will be applied directly above the upper level bookstores where the natural light is currently blocked, and it also helps to improve the visual comfort and reduce the lighting energy needs. And the advantage for this application is to enhance the daylight penetration and interior comfort. And it also generates clean electricity for daylighting, for lighting, and fans act as the radiant barrier, and it also reduces the heat gain as well. It also extends the roof life by shielding from UV exposure, and this strategy transforms a thermal and lighting weakness into a productive and passive energy solution. And the next proposed advanced technology solution is the smart adjustable louver for the ventilation. The louvers will be installed just below of the roof slab and on the upper facade to promote the stack effect ventilation and natural cross breeze for the whole building. And the advantages of this application is to improve the thermal comfort without increasing the aircon load, to reduce the mechanical ventilation dependency. And the next one is to maintain the heritage facade appearance through the discrete integration. And the next one is it is powered by solar to make it self-sufficient. This solution introduced a smart climate control while respecting the building adaptive reuse character. The next proposed advanced technology solution is to install the modular green facade system for the envelope upgrade. Is one of the problem of this building, whereby retrofit the facade with the modular green wall system using the steel frame planter boxes and climbing plants will be added to the front facade and potentially expand along the side of the rear elevation as well. And this application will provide the advantages of shading and insulation as well. It will reduce indoor temperature and urban heat island effect, and at the same time enhance the building biophilic aesthetic. The next proposed advanced technology solution is the rainwater collection and drip irrigation system. And this system will be applied at the front facade as well. The system will include to install a rainwater harvesting system with rooftop collection tank and a basic filtration unit and a drip irrigation network. And the tank will be integrated into the rooftop garden or service deck with the water pipe to the green facade and even toilet flushing system. And the advantage of this system is to reduce the dependency on the municipal water and provide a sustainable force for irrigating the vertical greenery. And it also at the same time improve the plant health and reduce the long-term operational costs. This is a summary of the proposed retrofit strategy. For the poor daylighting issue, the semi-transparent BIPV was installed at the rooftop to improve the daylight penetration into the upper levels while generating electricity, at the same time reduce the heat gain. And for the ventilation issue, adjustable aluminum louvers with thermal sensor is installed under the roof level to enable the natural cross ventilation and stack effect of cooling, reducing the dependency on the mechanical ventilation as well. And for the facade heat gain at the front wall, a modular green facade system with climbing plants was proposed to provide shading and reduce the urban heat gain, while at the same time enhance the facade aesthetic and microclimate as well. And the water conservation issue will be solved by the rainwater collection tanks and the drip pipe irrigation system, where to support the green facade and the planter maintenance, and at the same time it also reduce the potable water use for the toilet and the landscape irrigation as well. And together these strategies will upgrade the Rex KL into a climate adaptive, resource efficient, and a community responsive hub while respecting to its heritage and character. Thank you.